In Chapter 1, we are looking at the shape of a histogram to determine the shape, modality, whether or not it is skewed. We'll talk a little bit about kurtosis and to determine if there is a ceiling or floor effect. In order to do that, I'm going to use a variable called social interactions, which is the first variable here. And in this variable, there are quite a few cases, 94 cases, and these are the number of social interactions that people reported per week. So if I want to look at a histogram to do a visual inspection of social interactions and also to produce a frequency table, I can do that by going to Analyze, Descriptive Statistics, Frequencies. I know it says descriptives and we could go there for it, but we want to look at it through this dialog so that we can get the histogram produced at the same time. So I select my variable social interactions, I put it in the variables box, I go to statistics to see if it's going to give me anything interesting, and for this it's not really because we aren't looking at skewness or kurtosis coefficients, we're just looking at it visually, and we're going to talk about mean, median, and mode in chapter number 2. So we're going to go ahead and just stay put with what we have here. Oh, I guess we could do range because we did talk about the range. So continue, charts. We want it to produce a histogram, and why not? Let's put a normal curve on the histogram. Don't get confused though. The normal curve is not a way to tell if you have a normally distributed distribution. It's just there to approximate what the normal curve would look like superimposed on your histogram. So it won't be the telltale indication of any kind of kurtosis or skewness or anything. Click continue. Go to OK. By the way, the frequency table button should be already ticked on. That just is automatic. Click OK. And we have our output. Let me put that in the box. There we go. So we have 94 cases, 0 were missing. The range is 47, meaning that the distance between the lowest and highest score is 47. Now, if I go to the frequency table, I notice a couple things. That it has a frequency for each number of social interactions. So the number of people that had one social interaction is 2. That's 2.1% of my distribution, and the cumulative percent is 2.1. The cumulative percent is just the figure in this box plus the percent of the next box. So 2.1 plus 1.1 is 3.2, and so on. 3.2 plus 5.3 is 8.5. It just accumulates the percentage all the way through. Something that you'll notice though is that if there is not a case that had a particular number of social interactions, so let's find one. 11, 12, 17, 18, 19. Okay, so there were 0 people that had 20 social interactions. So SPSS omits it from the frequency table because it allows it to save a little bit of space. So just know that it won't put it in here, even though we know that customarily you include the frequencies, or excuse me, you include the frequencies even if nobody had it. So let's scroll down and look at the histogram. So as I look at this histogram, I notice that it appears to be skewed to the right, meaning that it has a heavy tail on the right. And as you can see, the normal curve that they superimpose on it really doesn't do a whole lot except for indicate where the mean is. We haven't talked about that yet, but that indicates where the mean is. But that's about it. So we see that this histogram has a right tail on it, meaning that it's skewed to the right. It looks to have one main curve to it, so that means that it's probably unimodal. Even though you have this little uptick at the end, that's not really another curve, that's just an anomaly in the data, it's fine. It probably also has a floor effect. I know that fewer people have this range toward the bottom number, but it seems to be that the scores are kind of piled toward the bottom of the scale. Let's see. The kurtosis. It doesn't appear to be overly peaked or overly flat. It appears to be a normally distributed in terms of kurtosis distribution. And like I said, it's skewed to the right. So any other ideas that you have about that you could express, but it looks like I covered everything that I'd want you to cover. Something that you'll also notice is that, well, they're called bins, but there are bars that appear to have more than one frequency. For example, there are 2.5 bars inside of 10. So that means that all the frequencies 0 through 10 are accumulated into 3 bars. And that's okay to do. It's more or less a grouped frequency histogram at that point, and that's okay to do. SPSS does it automatically. I could show you how to just separate it out into individual scores. It's kind of a pain in the butt, and it's okay that we don't do that. So this is what you would produce for your data analysis for Chapter 1, and you would discuss your findings just in plain language in that last paragraph. So go ahead and get to work and have fun with it.